Welcome to AlexGs Aquarium, everybody. Today I've got a massive update on the 4,200 gallon display. I know it's been several months since I've made an update on this aquarium, but I have been hard at work trying to get this build to the state that it's at today. Waterproofing is about 90% complete on the aquarium now, and at this point there's just some touch-up work that needs to be done, and I'm probably not going to do the absolute final waterproofing on places like the bottom until the glass is installed. But for the most part, waterproofing is now complete, and that is what today's video is all about, is waterproofing and all the fun work that went into getting this done. Took a lot longer than I thought it was going to take. So if you want to stick around, this is going to be a long video, and I'm going to go through the waterproofing in general and just describe exactly what I've done here to complete the waterproofing of the aquarium. Then I'm going to talk about the all-important steps of preparation and testing to get waterproofing done. And finally, I'm going to start going into detail here on how I completed the waterproofing and all the steps I took. It's just going to be kind of an A to Z on the process for this tank. With that, let's dive into the waterproofing of the 4,200 gallon aquarium, which all started with fiberglass. Lots and lots of fiberglass. In fact, I laminated 2 layers of fiberglass to this aquarium. The first was a chop strand mat layer. The second was a woven cloth. And those layers of fiberglass were applied to the bottom of the aquarium, the bottom seal beam, which holds the bottom glass in place, and the top inside face and bottom of the top aquarium brace beam system. And adding this fiberglass in here is 2 things. One, it adds a very thick layer of waterproofing, which really just helps with an aquarium this size. And 2, it adds an enormous amount of strength. It provides things like impact resistance to the bottom of the tank in case a rock or something were to fall. And also for areas of the aquarium like the top aquarium brace beam structure, where you have these 4-inch by 4-inch beams, it adds an enormous amount of rigidity and strength as well to these beams. So they just are a lot stronger overall to keep this structure intact and just increase the strength overall. Now, as you can see, I did not just stop with fiberglass. I finished the waterproof coatings on this aquarium using Pond Shield epoxy, which is why these beams, the bottom of the tank and the canopy are all white. And also on the bottom seal beam here on the outside, you can see it's black, and that is because I have applied several coats of Pond Shield epoxy. This stuff is great. I've used it for years in plywood tanks, been very happy with it. I wanted to use it in this build, and it is doing a number of jobs here. All the areas that are in the submersion zone have Pond Shield, and then areas like the top aquarium brace beam on the top and the bottom and the inside, where they're in the splash zone, spill zone, they got an application of Pond Shield, as well as the bottom seal beam for the same reason. I want to protect this area of the tank from splashes and spills, because this plywood edge is probably one of the more vulnerable places in any kind of tank that you use plywood, just because that edge, it's very easy for moisture to get in there. So I wanted to Pond Shield epoxy everything, because inevitably there's going to be some splashes and spills. Finally, the canopy of the aquarium was also coated with 2 layers of Pond Shield epoxy, and what this is doing is protecting this structure from all the humidity exposure it's going to have. When this build is complete, this canopy is all going to be sealed off. It's going to have a negative pressure applied to it using ventilation fans to make sure that all the moisture that's generated from this aquarium stays in here and doesn't get out in the room. That's an overview of what I did for the waterproofing on this aquarium, and I gotta say, it was a ton of work to get here, which leads me into my next segment of this video, preparation and testing work. For anyone out there that's a DIYer or someone interested in DIY or just curious on builds, one of the most important steps you could take in any part of a build is to take a pause and do prep work, and if necessary, do some testing to make sure what you're about to do is actually going to work and you understand the methods and practices that you should have before you go ahead and start the big job, where if you make mistakes, they could be pretty costly and cost you a lot of time and money trying to go back and redo something that just did not work out well. I spent a week doing prep work and testing before I started any of the waterproofing. Now, because I did these both in the same week, I was kind of switching between doing prep work and testing of products and methods and answering some questions I didn't have answers to, which allowed me to really take a step back and take my time, which is really important in this step. You do not want to rush prep work or testing work. Take your time here, don't cut corners. I'm going to go through all the prep work I did on this aquarium first, and then we'll talk testing. The preparation work all started with trimming the bottom seal beam. This bottom seal beam had a lot of layers of plywood that just weren't quite even. There's 6 layers of 3/4 inch plywood there, and inevitably there were some pieces that were cut a little bit longer, which was intentional because when I was gluing and laminating things, I didn't want to take the risk of something being too short, so I was fine with something being a little longer than it should be, knowing it could be trimmed later. I had about 40 feet of trimming to do. Unfortunately, I had to use a Japanese handsaw for the majority of it. As a matter of fact, 30 of the 40 feet. It was just too precise at cutting. I didn't have any tools on hand that could do the job right, other than a reciprocating saw, which just couldn't get it done right when it was a precise cut. So, not a fun job, but it had to be done. But with that done, it allowed me to apply waterproofing a little easier, and also it is going to allow me to add my finishing boards to give this a nice furniture grade look later on. That wasn't the fun part of prep, but that allowed me to get to the next and most important part of this, which was removing excess wood glue residue, loose wood fibers. I inspected for any veneer on the plywood that might have been loose or not quite adhered properly, and I went through the aquarium a half dozen times, searching everywhere on here. I went through in multiple directions. After 4 times going through everything, I took the top aquarium brace beam system apart, flipped it all around, made sure I cleaned up everything as best I could. So every time I went through, I always spotted a few new areas of wood glue or some little wood fibers that needed to be cleaned up. And for this job, I just used my vibrating saw attachment here, and the same thing, the little vibrating sander, or just get out the old sandpaper and take off that wood glue or little wood fibers. I will say that little vibrating saw is great if you have real thick chunks of wood glue residue. It tends to heat it up really hot and it kind of gets a little bit gummy, but it's easy to just pull it off of the wood and take it off. If you let it dry, it'll just harden back up in place, but it does take a little bit of pressure off you from just doing tons and tons of sanding to remove that little tiny glue spot. It didn't stop there with prep work, because I also took this as an opportunity to make sure any repairs I needed to make or corrections before I started waterproofing were completed, and I had one that was really important that I needed to get done. When we talk repairs, I want to bring the attention to this section of the 12-foot beam on the short L side of the tank. This particular beam, when it was assembled, unfortunately, was not assembled straight and had a slight jog in it going this way. That caused this beam to have a sag in it. And it was about a half-inch sag over the 12 feet. It mainly concentrated its dip over here. Now, while this probably wouldn't have affected the structure long term, because the seal would have just been thicker here. It was going to cause a lot of problems. It was unsightly, and well, frankly, I made a boo-boo and I needed to fix it and do it the right way. I thought about several ways to fix this. Ultimately though, what I needed to do was cut through 2/3 of this beam, and that allowed the beam to just straighten out and relax. It made, and you can actually still see it a little bit here through the pond shield, there's a little strip of wood, and that's because what I did was, after I cut through 2/3 of it, I wedged it to straighten the beam out. In fact, I actually held it up, I actually placed it up here on its little temp holders I had at the time, so that I could make sure with this beam and its wedge in here, it would sit nice and level. So I did actually have to put the wood wedge in just a little bit more to hold it level, so I pulled that sag out of the beam all the way. Once I had that done, I put wedges in the front and I glued them in, and then the rest of this section, because I had to cut through the whole beam, I turned this into a solid 4" by 4" block, the same design that I used on my end beams here that do not have cross braces. So it's got screws, 3" screws going up and down in it. There's 7 or 8 of them in here holding it all together. That was all glued and screwed into place, and that was what I had to repair before I moved on. Once I had this repair done, I took this 12-foot beam, the other 12-foot beam opposite of this 6-foot beam here, and the 6-foot beam on the other end of the tank, and moved them out to the garage because I decided that's where the fiberglassing was going to begin, was outside. I still had a lot of cleanup to do though. While I did have everything removed in terms of wood fibers, wood glue residue, I had made a giant mess down here doing that exercise. So I started a massive cleanup effort from the very top of the canopy all the way to the carpet. I did dusting, sweeping, picking up large debris, vacuuming, and then more dusting and sweeping until I got everything cleaned up here and as relatively dust free as I could. Then it was time to tent this entire aquarium. Because I am going to be working with polyester resins for fiberglass that have some pretty dangerous fumes with them, this is one of those products where the well-ventilated space when you're using it is incredibly important. So I decided to tent this entire aquarium in painter's plastic, and doing that did a few things. One, it would help contain all of the VOCs, it would help contain all the vapors, dust, and also just prevent things like pond shield epoxy from getting flung into the carpet or the wall as it was being applied high up in the air, which happened a lot. So that tent was very important. Now, it wasn't just simply a tent. I did need to add that well ventilated piece for that. So what I ended up doing was buying 2 AC Infinity 4" inline duct fans, and they move about 205 CFM per minute each. I decided I was going to need them for another DIY project, but I'd get them right away so that I could use them to vent this tent outside. So my escape window on the far side of the basement, I made an insert on it, added in a couple of ducts. I started with one vent fan sucking air outside, which negative pressured this tent. I left an entrance actually on this side of the tent, farthest away from that window, so that I had a way to get in and out of the tent, and at the same time it would allow fresh air to come in. So that tent, I taped all the vertical seams, I taped the bottom and the top seams a little bit more loose, but it was a huge difference when that fan was turned up all the way. You could really see the side walls of the tent get sucked in, so I knew it was definitely moving a lot of air. And just a word of caution here for anyone that's using vent fans this way, when I added a second one, I was venting out 410 CFM per minute. And it's very important, if you are doing something like that, that you think about the negative pressure you could be causing in your home itself. If you have furnaces, hot water heaters, or any appliances that use a regular chimney pipe. You just got to be very mindful that you're not sucking so much air out of the house that you reverse a chimney. That's really bad because you could suck carbon monoxide in your house. For this, I would always open up windows. I also have high efficiency furnace and hot water heater, so they are in a full little closed loop there, so I don't have to worry about chimney being reversed because they don't have a chimney. That was the final step of prep work, was tenting and ventilating the space. So that's all the prep work. Now let's talk about testing. I want to preface, I spent somewhere between 15 and 20 hours doing research on the application of fiberglass to wood, layering fiberglass, learning the methods, the tools, the products, everything and anything that I could to better understand the process that I was about to undertake. Because in reality, I have no experience with fiberglass walking into this. Sure, I did a little bit of fiberglass work in my previous plywood tanks and a little bit in a boat I used to own many years ago, but that's nothing close to what I did for this aquarium. So I spent that time, and it was very valuable, which really helped me when I got to the point of testing. And testing for me was really about three things. One, I wanted to answer some questions that I could not find the answers to in my research, whether it was just too many opinions or not a lot of knowing, and even some things kind of came into, well, you're just going to have to try it out and see if it works with the products you're using. And that is always something that gets me concerned, which is why I wanted to do a couple of tests up front. Two, I wanted to test the products that I purchased to make sure they all work as advertised or semi as advertised. And finally, I wanted to understand if the methods that I was choosing to utilize for this build and the waterproofing I needed to accomplish was going to work. Now there's a few things that I need to mention here before I get into actual testing, and the big one here is safety. I really mean it when I tell everybody this. This hobby is supposed to be fun for your enjoyment, your family's enjoyment. Do not take the risks with this stuff. I'm not going to lie to you. Fiberglass resins and several of the other chemicals I had to use, such as acetone, you do not want to have bad exposure to them. Wear your safety glasses. Wear a respirator. Wear a full body Tyvek suit. I'm going to admit, I didn't wear the Tyvek suit a couple times working with the fiberglass, and I deeply regretted it because I had a horrible case of the itchies. And I had to throw out all the clothes I was wearing during that because I just got fiberglass all over them, and there's just nothing you could do to get that out. If you're going to be working with, saws or other stuff, wear some ear protection too. Trust me, I got a whole family that did skilled trades for their entire lives, and they all have hearing problems in part due to the work that they did. Just follow the instructions of the products you're using. So that's my safety PSA. Always follow the instructions for the proper safety equipment. Now when it comes to products, I do want to specify that I was using True Composites polyester fiberglass resin. I first saw this product on Aquarium Domain's channel for a couple of his DIY builds, and I purchased a gallon with it. It worked well in testing, so I did end up using it for the whole build, but this was the fiberglass resin that I used, and while using it, I was mixing it to a ratio of 1% hardener. Now in addition to that fiberglass resin, I purchased a whole bunch of products which I've got on the screen right now. Probably the one that everyone's probably going to look at and say, what is that for, is the wood flour. The rest of it's all either tools or products I use to complete my waterproofing on the 4,200 gallon display. When it came time to do the actual testing, I needed to use a couple of test pieces for all of my tests. So what better way to do that to make a small test section of the top aquarium brace beam and a small section of the bottom of the tank with a small piece of oak, which represents the bottom seal beam of the tank. Now, when I went ahead and did this testing, I first wanted to answer a couple of questions I didn't have answers to. And the first one was, how does True Composites polyester resin react to Type Bond 3 wood glue residue? In past experience with products like Pond Shield, they do not react well with wood glue residue. They repel away from it, they won't adhere to it, which makes it very important that you remove that excess glue, which I just talked about in the prep work. And I wasn't sure how a polyester resin would react because I've just never worked with them. So in my test pieces, I intentionally put some glue on the boards. A little bit of it was a puddle. Some of it was just smeared on, exactly how it would be encountered if I missed anything. For the test, I simply mixed up just a couple ounces of polyester resin at a 1% hardener ratio and applied that to the board where the wood glue residue was present. It cured, and as far as I could tell, had no effect. It went right over the top of the wood glue like it wasn't even there, and doesn't seem to flake off or not adhere to it. So that was good to see that if I missed a little bit, it would be all right. And the second test that I did was for my DIY wood filler. And I'm sure you might be asking, why are you going to use a DIY wood filler? There's a ton of commercial products out there for structural wood fillers. Just use one of those. I felt the same way, except when I started doing a lot of reading and articles and videos, listening to what people had to say in the forums on boating. And yes, I know forums are very opinionated, but the one thing that I saw in common when it came to wood filler was a lot of people said, maybe not gonna work for you. You gotta test it. And that concerned me a little bit. But I also started to see a lot of people mention, well, just use the wood flour method. Then you don't have to worry about that, and it's very strong and you won't have problems. And I'm like, oh, great. What's the wood flour method? So I looked that up, and that's why I got this product called wood flour, which is literally sawdust that's sifted down to the granularity of flour. And I gotta warn you, it's got a pretty strong warning on here. Don't even open this container without a respirator on, because you just don't want to breathe in those fine wood particles. And I have to admit, after seeing this, it's very similar to a technique that I use when woodworking, where you mix wood glue with sawdust to make your own wood filler that's sandable and has some structure to it. The change here is that you mix up a small batch of your polyester resin and you start adding wood flour to that resin. And you add it until you get to a nice creamy consistency. You don't want a paste, you don't want a syrup, you want a nice thick cream. I know it sounds like it might not work, but honestly, I tried it out, tested it out, and it worked wonderfully. It's sandable, it has a structural element to it with the wood flour, and best of all, you are using the same polyester resin, so you don't have to be concerned that when you apply resin or fiberglass that it's not going to stick to the wood filler you use. So that worked out well. Highly recommend. The tests were successful. Now when it came to testing method and products for the fiberglass, I wanted to do the same method on both test pieces and find out if this was going to work. And the method is as follows, using polyester resin mixed to a 1% hardener ratio. I would first take my piece of wood, sand it down, clean it off with some isopropyl alcohol and rags. Then I would apply a layer of polyester resin on its own, no fiberglass. This is an important step as you want that resin to be able to soak into the wood and not affect any fiberglass that is laid down on it, as it has a possibility of causing a weak lamination if you don't do this step. After applying that resin to the wood, I had all my fiberglass pieces staged up, starting with the chop strand matte fiberglass. I applied that layer to the bottom test piece. Worked wonderfully. As it was applied, I went ahead and used fiberglass rollers to just roll out bubbles. Again, a real basic tool, works really well. One quick tip here, make sure you have some acetone on hand and some extra little mixing cups. You want to clean those rollers off as soon as you're done with them. As a matter of fact, I always kept a little cup of acetone there. It will not just clean off the resin and make it inactive, that resin will remain in the acetone until that acetone evaporates away, and then the resin will activate. So just something to keep in mind, which is actually something that comes back to haunt me in waterproofing a little later on. After applying that first method of chop strand matte fiberglass, using the fiberglass rollers to get bubbles out, smooth it out, I went ahead, let it tack up, and then I applied a woven cloth fiberglass over the top, did the same exact thing. And one thing I will note here, while I was making these test pieces, I was recording how much resin I was using for each test piece and the square footage of it, just to have for a record, because I only bought 1 gallon and I needed to calculate how much resin I'd need for my whole job if this worked properly. I repeated this same process on my small section of top aquarium brace beam, and I found out a couple hard lessons with this testing, which is exactly why you want to do testing. And what happened is I tried to take a single piece of fiberglass and fold it over 3 sides of the beam that were getting fiberglass. The chop strand mat will not do outside degree 90s. You could wrap it around and it'll look like it's going to hold, but it will start to flare out. Now the first test piece I did with this, it actually did fail, and it stayed flared out and fully cured, which in fact created another dilemma for me, which is how am I going to make repairs to this stuff and cut fiberglass, because I kind of neglected to have a tool for that. However, I did find a solution to that problem. It's my little vibrating sander saw. I've used little saw blades on it, I've used sanders on it, but for fiberglass I found these abrasive tile and grout blades work really well. As a matter of fact, I chipped this one because I used it so much I had to get a second one. But these actually work really well at cutting through fiberglass. They are very messy though. You must have a vacuum to do dust collection immediately while you're cutting, or it's going to get everywhere. Again, want to wear a respirator while you're doing that. But learned a valuable lesson there, that the fiberglass wasn't going to work on outside 90s. And once I completed that, I did the same process of adding the woven cloth, and essentially what I learned from this was method was all going to work, products all worked well. However, the one thing I needed to do was for the top aquarium brace beams, I could not use a single piece of fiberglass to go around all 3 sides. Also, trying to apply fiberglass resin to sides that are vertical where the resin could slide down is incredibly wasteful. You drip resin everywhere, it's a mess to do, and it just doesn't turn out well. But once I had that done, I went ahead and did use a little batch of Pond Shield epoxy to just coat a small area of the fiberglass just to see how it would work. I roughed it up, cleaned it off, applied the Pond Shield, and it did adhere to it pretty good. It's not quite as strong as a bond to, say, wood, where it physically soaks into it, but nevertheless it is a very strong bond and worked out pretty well. It took quite a bit of gouging at it with a screwdriver in order to get it to dislodge from the fiberglass. So it overall worked really well. I was satisfied with the testing. And with testing complete, let's go ahead and dive into the waterproofing itself. And when it came to the application of fiberglass to the aquarium, I started with the 4 beams that I took out to my garage, the 2 12-foot beams, one right above me, one opposite, and the 2 6-foot end beams. There's one down here and one at the very far end of the tank. I wanted to start with these 4 beams in the garage with fiberglass because they were the smallest pieces I had to fiberglass, and 2, they were the only ones I could fit out of the house because the 24-foot and 30-foot beams won't physically fit out of the house. So I needed to do, I wanted to take those beams outside so that I could practice my fiberglass method on smaller pieces. At the same time, I wanted to do this in a well-ventilated space like my garage, where I could have the doors open in the middle of summer and not have to be concerned with vapors, because I really was not sure just how strong this fiberglass resin was going to be. So with that, I want to explain the method that I use to fiberglass these beams. And again, I'm going to preface, I probably tried over a dozen different little iterations of applying fiberglass, and I'm going to only explain the one that had the least amount of problems in terms of repairs and it's not the most time efficient. This isn't as fast as I was able to do it with some jobs, but it minimized the need for repairs, and it just looked a heck of a lot better. I got my beams and immediately got out my blue painter's tape. I taped over all the butt joint seams that are wood to wood that I did not want resin or fiberglass on. The pocket hole jig screw holes that I needed for top brace assembly were also taped off. Once all the blue painter's tape was down, I got out my fiberglass, starting with the chop strand mat, and I pre-cut pieces for each side of the beam, and I would label them with a piece of tape and just came up with a little numbering system to say what beam they were and what side of the beam they were, and rolled them up and set them aside. And I did that for the chop strand first, then the woven cloth, and once all of that was completed and those pieces were staged up, it was time to start wood filling. So for DIY wood filler, I went through and filled all the screw heads, any knots, cracks, gaps in the wood, and would go through and do sanding after it cured up, which usually in an hour or two you are good to sand that DIY wood filler. Clean it off and apply another layer of DIY wood filler if necessary, and just repeat that until you're satisfied with wood filler. Then I set the beams with this side actually facing down and applied my polyester resin to all three sides of the beam. And so with this, you can allow the resin to fully dry overnight. If you do that, you need to sand it down with some 40 to 60 grit sandpaper lightly, rough it all up, clean it off, and then you're ready to apply fiberglass. If you just want to let that resin tack up for 45 minutes to an hour is what worked for me, and I just wait till the surface was nice and tacky. I would get my chop strand mat fiberglass out, put it down on the beam with a layer of resin and soak it all the way through, roll it out, get any imperfections or issues I could out with it. I would leave it overhanging on the sides and I would just be fine with it. Once it sat for about 45 minutes to an hour and it was starting to tack up really nice, if there were no imperfections on that layer or issues that needed repair, you were good to go. If there were little repairs that had to be done, you could get that little abrasive blade out and grind those little areas off. If you need a little patch, you could make one and apply it right away. But oftentimes when I did this right, I never had any issues doing it one side at a time. So I would then go ahead and apply the woven cloth fiberglass. I found with the woven cloth I was using, it was much better to just put the cloth down where you needed it and then just soak it through with resin, as it was more difficult to try and wet everything out and apply it while it was on a wet surface. The woven cloth takes a lot less resin to soak up. Once both layers of fiberglass were cured, I would then go through and do trimming on the sides of the beams with that abrasive blade. The best thing to do is have a shop vac right there. Get all the dust you can immediately. It's very messy. You really need the Tyvek suit, and you also need to have the safety glasses, and the respirator is a must-have. In the garage, I didn't use a shop vac. It took me several hours to clean everything up. But once that's all done, you repeat the same process for the other sides of the beam. Don't worry about things like cross brace holes. Just fiberglass right over the top of them. You could drill them out later. Once all the fiberglass is applied to all the sides, I did inspections, make sure there was no patching needed. Anything that was a significant air bubble that I saw, I would grind it out and patch it with a little piece of fiberglass. It's really easy to do, and it's well worth the effort to do that. Once all that patching was done and I was satisfied fiberglass was good, I drilled out the holes that I needed for cross braces. I did not drill the ones I did not need. Then all sides of the beam where it was fiberglass were sanded down with 40 grit sandpaper. This is just to rough the surface up for Pond Shield epoxy, give the beams a good cleaning and a dust off, and they were good to go. So a lot of work to get these beams done, but well worth it. I repeated the same process for all 4 of these beams. From there, it was time to move into the house and I decided here I had the 24-foot and 30-foot beam to complete and the aquarium bottom. Now I elected to start with DIY wood filler for the aquarium bottom first. I figured it was easier to just get the bottom completed, and I went through several rounds of filling the bottom seams. The most important one that I had to fill was around the bottom seal beam. There were some gaps here that needed to be filled in really good with the structural wood filler. I also went ahead and took the plastic spreader I was using, just clipped off the corner of it so that maybe it was about a 2mm corner cut off, and I used that as a final spread of DIY wood filler around the entire corner perimeter, all 84 feet of it, just to take that sharp corner off the inside there. It just makes it a little easier for the fiberglass to go in without having to get jammed into that super tight corner. Once DIY wood filler was completed on the bottom, I moved on to the exact same technique for fiberglass on the 24-foot and 30-foot beams. At this point, using resin in the basement had really necessitated the need for the second ventilation fan, which brought me up to the 410 CFM per minute of airflow through the tent, and it worked like a charm. When I did that, I'd open up all the windows I could outside, making sure that I was mindful of the direction of the wind so that the fumes getting ventilated outside were not getting blown right back in through a window. It really wasn't the most fun thing to do when it was a hot day, but well worth it. Within about 6 to 8 hours, the vapors would pretty much be cleared. So just something you need to take your time with. And then of course, you know, having the tent here was invaluable for all the cutting and grinding on the fiberglass. Just kept all the dust inside the tent, and the Tyvek suit and the shop vac were invaluable for this too, and just keeping the dust level down and not getting it all over my basement or harming my running system of 2,100 gallons. With the 24-foot, 30-foot beams complete, it was time to move on to fiberglass on the bottom of the tank. I prepped all the fiberglass for the bottom seal beam perimeter first, followed by both layers of the bottom of the tank. Now I do want to point a couple things out. First off, for the bottom seal beam, I used continuous pieces of fiberglass for every single side, including the 30-foot sides. I did not want any seams, especially on the glass seal face. I wanted it to be as even as I could, and putting any kind of overlapping layers would have made it more challenging. However, on the bottom, I needed to make sure I had good overlap. So the first layer of chop strand mat fiberglass, I went from front to back on the tank, so they were roughly 6-foot wide sheets by 39 inches, and those were stacked out all the way into the tank and prepped. Then they were put away with a similar labeling system that I used for the beams. Then for the woven cloth, I elected to roll them out long ways, so I had 2 long rolls 39 inches with a big overlap in the center, going the whole length of the tank. And then I subsequently changed direction for the 12-foot short end L here. Now, the fiberglass for all of this was painful. The bottom seal beam and that little 2.5-inch vertical piece there was just an absolute pain in the butt to do. Not gonna lie, it wasn't fun. Unfortunately, the resin tended to have a little bit of a sag in it over time, which made a really terrible bump on this bottom seal beam, which resulted in the need to do an enormous amount of sanding and grinding to get it straightened out again. So that was not very fun. Moving on to the bottom of the tank, I went through and got the chop strand mat layer down. It took me 2.5 days to get that done. It was just very labor intensive. You have to work very fast. The one thing you don't want to do is mix more resin than you could use. And while I never really did that, I did have a couple instances in the garage and here where maybe I put too much hardener in, or for whatever reason didn't mix it right, and it went ahead and prematurely activated on me. And probably the most notable one is I had about a pint of resin that turned on me, and this stuff literally goes from workable to hard jello within a few seconds. It is amazing how fast it will turn on you, and there's not a ton of indication other than your little internal clock going, you're running out of time. And when that batch turned on me, I was in the middle of laminating a sheet, so I quickly got another mixing bucket out and got another 3 quarts mixed up and quickly got it out. And when I was doing this, and I kind of stopped for a little break because I had a sec, I went, you know, I should probably check that resin that was in there, because this stuff can get pretty hot in a large quantity. And oh boy, was it hot. It's so hot, in fact, I thought it might melt the plastic it was in. And I almost, if I would have held it with my hands, I'm sure I would have been burned. So I quickly ran that outside to go sit in the driveway and cure. So something to always keep in mind, never mix more resin than you need. Once I had the first whole layer down, unfortunately I ran out of resin and decided at this point, instead of waiting several days for resin to show up, that I would go ahead and start Pond Shield epoxy on the canopy of the tank. Another very painful process, but I put 2 coats of Pond Shield epoxy on the canopy. At this point, I had plastic down everywhere to protect the fiberglass from getting miscellaneous drips. And after this process was done up here, I removed the plastic and proceeded with fiberglassing the bottom of the tank as well. With the bottom all fiberglassed out, I did sanding and patching in a couple rounds. Once I was satisfied it was all good to go, I started the Pond Shield epoxy application on the bottom. And for this, I really wanted to match what I did on the seal beam surfaces as best I could. So the bottom seal beam and top seal beam have 2 coats of Pond Shield with just a little bit of a 3rd coat patch and some thin spots. And the bottom of the tank, I put extra thick coats on. I laid down 2 full thick coats, and then from there, just because of the unevenness of the fiberglass with all the layering, there were some areas that still you could see the fiberglass through. So I just started working those areas out as needed by just sanding the Pond Shield and then reapplying a thick coat on there. Now I still have some touch-ups to do in the tank at this moment, but it worked out good. I applied Pond Shield to the bottom of the tank, or the bottom seal beam as well, the inside of the top aquarium brace beam, and everything here turned out pretty good. One of the final things I did was for the top aquarium brace beam system, I put in some more permanent stanchions here to hold this up. They're just made out of 1x4 pine boards, and I didn't Pond Shield epoxy them because honestly they're not going to be exposed to direct water very easily, and they're all going to get covered with some furniture grade boards. So I'm not too worried about a little bit of splash or spill there. I'm more concerned about the structural elements of this build being protected, or the places like the canopy that are going to get that high humidity exposure. So that's why that still has bare wood on it. Just wasn't worth the time to apply epoxy to something that's going to get covered anyways. So overall, the waterproofing all turned out really good in here. A couple lessons learned, I'll say though, is with the Pond Shield on the fiberglass, the one thing I have noticed, and it's something I kind of expected, is that because it's not wood where it soaks in, if you take something really heavy like a sawhorse or a hammer or something and you strike it at an angle or drag it across with a heavy weight, there is a chance that you could tear the Pond Shield epoxy. I had a couple little instances of it. I mean, the sawhorse I was dragging probably had over 100 pounds on it into that little tiny point, and it was probably just a little corner of it that got hooked on the epoxy and dug into it. So I had a couple little missteps with that. I'm not really worried about it though, because this entire bottom is eventually going to have another layer of protection on it as well. And the fiberglass itself is also going to act as a waterproofing barrier. But the rocks aren't going to be directly on this. For the aquascape, they're all going to be on PVC sheets. And I've got some other plans for the rest of the bottom of the tank. So I want to close the video off with just saying this was an enormous amount of work. I can't relay just how much work it was, because I still don't believe it myself. And as far as next steps on the build go, I've already taken measurements for glass and I am seeking quotes at the moment. I've also started planning my overflow plumbing in the back, because before I decide where the holes are going to go back there, I figured it would be a good idea to have the plumbing drain manifold built so that I don't pick a poor choice with hole placement and go, well, I'm really in trouble now. So some things to keep in mind if you're doing this. Other than that, I'm happy with the way the waterproofing turned out. It looks great. Next steps here, once I work through everything with the glass, I'm going to turn my attention towards the canopy of this aquarium. I have to fill in all these holes up top with some waterproof panels. Then I'm going to get my plumbing, electrical, light racks, all of that stuff done inside here. It's going to take a long time for glass to get here, so I've got plenty of time and I'm not in a rush. As I get the canopy all completed out, from there I am going to start working on the exterior of the tank and putting a furniture finish on everything here. A ton of work to go. It's really coming along though, and on the plus side of things too, I've had some positive news in the aquarium system running back there. My long battle with zinc, I think, is coming to an end. So that's the video for today. If you have comments or questions, go ahead and leave them down below. Get to them as quickly as I can. And if you like the video, go ahead and give it a like. If you want to see more, go ahead and hit subscribe. I don't post videos too often, and again, apologize it took so many months to get one out. It was just literally so much work to get this done. I didn't feel it was fair to put a video out before this work was complete. But thanks for watching, everybody, and I'll see you on the next video.